Hello, this is COS 505. So we'll cover Chapter 1 of the Essential of Computer Organization and Architecture by Nolan Labor. This is the 5th edition. So topics to be covered: introduction, overview, computer system, system components, classification of computing devices, standard organizations, history of computers, Moore's law, computer level hierarchy, von Neumann architecture, parallel computing. So chapter 1 is basically the introduction. So historical overview, milestones, different kinds of terminology, basic components, various logical level of computer systems, von Neumann computer models, parallel computing. So, computers have freed us from various tedious tasks. Computers are more complex than ever before, but the origination of computers is fairly straightforward. So computer scientists are concerned about writing complex programs and algorithms. Complicated algorithms can take a long time to write or computationally infeasible. So computer program optimization and system tuning are important motivation in learning how computers work. So understanding various circuits and components that are used to create a computer, this is called computer organization. So computer architecture focuses on the structure and behavior of computer systems. Computer architecture is a combination of hardware components and instruction set architecture. So computer systems, they run algorithms that run other algorithms. So any task that can be done by hardware can also be done by a software. So a basic level of a computer, it contains a central processing unit, memory to store both data and program, a mechanism for transferring data to and from the outside world. So the most important system is the operating system. Technically, computers are the hardware only, but it's common to consider the hardware and software as part of the computer. So what are computers? So we've got so many devices that we have, our smartwatches, phones, we can't leave home without it. We have computers in our cars everywhere. So we classify computer systems into 5 categories. So you've got supercomputer, mainframe, personal computer, mobile devices, and embedded systems. So this is, you'll get to learn what these mean. So this is a computer advertisement. So by reading this chapter, you'll understand these terminologies that are referred here. So these are different classifications. So you may have heard of gigabyte and terabyte. These are fairly common. Also petabytes, millisecond, microsecond, nanosecond. So you've heard of these. So these are common prefixes that are in the computer organization and architectural world. So different clock frequencies, you heard of hertz, megahertz, gigahertz. So today's computers operate in gigahertz. So this is a teardown of a computer device. You can see the components here. This is an older computer, so you see the floppy drive here. Various components. It's good to have an older computer which you can tear down and kind of understand the skeletal structure of it. Different classifications. So you've got your serial advanced technology attachments, integrated drive, electronic universal serial bus, accelerated graphic ports, liquid crystal display, graphic processing unit. So a lot of gaming computers, you will hear this, GPUs. So here you've got different components of the computer again. You got your battery, mini USB port, removable SD slot. So another teardown of a tablet computer here. Different kinds of organizations that are used to develop standards. You got the IEEE, ITU, ANSI, ISO, ANSI, American National Standard Institute. This is fairly common. You may have also heard of ISO, International Organization for Standardization, ISO, International Telecommunication Union, ITU, IEEE, Institute of Electrical and Electronic Engineers. So if you're a student, you should be a member of this. I think the student membership is fairly low cost. Kind of the history of computer. You got the generation 0 to 4th generation. You got your mechanical calculation machine, so 1642 to 1945. The abacus, you can think of that. The first generation, the vacuum tube computer, 1945 to 1953. The second generation, transistorized computer, 1954 through 1965. The third generation, integrated circuit computer, 1965 to 1980. The fourth generation, VLSI computer, 1980 to, and so forth. So this is kind of the history of computer. You got your vacuum tube here. You got your transistor, microchip, integrated circuit. The vacuum tube used to have bugs live here. That's where you get, and when people say bug in your code, it came from this vacuum tube right here. So there was actually a bug that was living there. Moving on to Moore's law. So this is the observation. The number of transistors of an integrated circuit IC doubles about every 2 years. This principle is still used in some cases, but it was originated in the 60s. The computer level hierarchy, you got your user, digital logic, high level language, C++, Java, so forth, assembly language, system software, your operating software machine, controls, and the digital logic. Cloud computing, this is fairly common these days. You've got everything that it's in the cloud. You hear this term or jargon a lot. So it's kind of like where we kind of rent resources from storage, network, application, and various other things. The fragility of the internet, we are really dependent on internet. Farmers are using internet, so there may be security issues and other vulnerabilities that are going on. That's important to think of the internet. So we're very dependent. We can't live without the internet anymore these days. The von Neumann architecture, it's a computer, so it's based on a very simple computer. So you can go through this. So it's got a processing unit. So you got your arithmetic logic and processor registers. You got your control unit, memory that stores data, external mass storage. You got your input and output. So it's a very basic architecture of a computer, you could say. Then you got your parallel computing there. You got your multi-core computers and so forth. So parallel processing, dividing the task up into smaller tasks that can be, can work simultaneously. So with all these high performance computing, you have a lot of power that is being consumed. So it is definitely a strain on the power grid. So this is something that you really have to think about. So as we get into supercomputers or even quantum computing and so forth, there's like all this heat and power that's being generated and so forth. Let me know if you have any questions, post or questions or comments on Teams. So thank you.